Good morning, Algebra 2. We are going to be covering lesson 44. And hopefully you're watching this because this carries over into trig. So we're going to be rationalizing the denominator. So when I say rationalizing the denominator, that means we are going to be eliminating the square root formula from the denominator. So there's several things that we cannot have in the denominator. We can't have 0 in the denominator. We can't have a radical symbol. And we can't have I. So we're just going to start with today, rationalizing radicals out of the denominator. So for example, if I have 2 divided by the square root of, and then I'm going to change the 2 actually, so it doesn't look like anything. If I have 4 divided by the square root of 5, in order to eliminate that out of the denominator, I'm going to multiply top and bottom by the radical in the bottom. So in order to get rid of the square root of 5, I actually have to multiply the top and bottom by the square root of 5. So I'm going to multiply the top. These are different. They do not both have the square root, so I'm going to write them next to each other, 4 root 5. The bottom, however, both have the root symbol, so I get to write the square root of 25. Now you might be thinking, okay, that didn't get rid of it. Not yet, but what is the square root of 25? Well, the square root of 25 is 5, and that's how you get rid of it. Because when you multiply two identical radicals, you get the number inside. The top remains the same. You cannot reduce this, so do not cancel these. They are not the same. The square root of 5 is some crazy decimal, okay? And the bottom is a regular 5. 4 over 5 you cannot cancel, so that is simply your answer, 4 root 5 over 5. And that's how you say it. You can say 4 square root 5 or just 4 root 5. And so that is the answer. So knowing that, let's go ahead and jump into our lesson practice, which is on page 320. And we're going to jump right in. So here we go. Part A. They want us to rationalize 2 over 5 root 7. Now, I hope you notice in this one, I do have a 5 on the outside, but I don't care about the 5. I care that I have a root 7. So I'm going to multiply the top and bottom by root 7. And hopefully you're doing this along with me. You'll actually remember it if you do this with me instead of just having this on in the background, okay? So I'm going to multiply top and bottom by the root. So 2 times root 7 is just 2 root 7. I can't combine them because they don't look alike. On the bottom, I'm going to leave the 5, but I can multiply the root 7s because they have the same symbol and they look alike. So root 7 times root 7 is root 49, right? Which now becomes 5 times 7 on the bottom. On the top, I can't touch that because these are not alike, so I can't combine them. So I end up with 2 over 35, 2 root 7 over 35. Now remember, I cannot reduce these because one has a root symbol and one doesn't. So this is my answer. All right, let's do part B. Part B was the square root of 3 divided by 20. Now, using our rules, I can separate this. This is the same as the square root of 3 over the square root of 20. Now, it's your choice how we proceed forward, but I personally think it's easier to simplify the 20 now. So I realize that 20 is the square root of 4 times 5. And I know that the square root of 4 is 2. So I'm going to rewrite the bottom to be 2 root 5. Now, because I did that now, this saves me time later. So now I'm going to multiply top and bottom by the square root of 5 because that's what I have in the bottom. So I'm multiplying by the radical that's in the bottom. We don't care what's on the top. It's okay if radicals are in the top. The section is called Rationalizing the Denominator, not the numerator. We don't care if it's in the numerator. So on the top, these both have a root symbol, so you can multiply them. So I get 15. On the bottom, root 5 times root 5 is root 25, which is 5. So you can, the shortcut, if you know square root of 5 times the square root of 5 is 5, you can skip this middle step. So now I have root 15 over 2 times 5. So my final answer is the square root of 15 over 10. I cannot reduce these because root 15 is not the same. Like, it has a root symbol, this one doesn't, so leave it. I also can't break up 15. 15 is 3 times 5, and those don't have a square root. So this is my final answer. All right, now the next three are different. So part C, we're going to rationalize 2 divided by 2 minus the square root of 7. Now these are different. Okay, I have to multiply top and bottom by the conjugate. A conjugate, a plus the square root of b, the conjugate would be a minus the square root of b. So the only thing we change is the sign. So that means I'm going to multiply top and bottom by 2 plus the root of 7, and I'm going to have to do that to the top. So take note, the difference is that in A and B, I did not have a plus sign or subtraction. I had a single radical in both the top and the bottom. In C, D, and E, if you have your book out, I have multiple terms in the bottom, and that's why I'm having to do something different. So we're going to distribute. So 2 times 2 is 4. 2 times root 7 is positive 2 root 7. Over 2 times 2 is 4. 2 times root 7 is positive 2 root 7. Now distribute the negative root, so negative 2 root 7. Notice I just wrote things next to each other. And then negative root 7 times positive root 7 is negative square root of 49, or you can just put negative 7. Okay? In the top, these are not alike, so there's nothing to combine here. So I just have 4 plus 2 root 7. In the bottom, one of these should be positive and one is negative, so these cancel. Now on the bottom, I now just have 4 minus 7 because the square root of 49 is 7. So I'm going to rewrite this because on the bottom, I have like terms. 4 take away 7 is negative 3. Now you can leave it that way. That is my answer. So we're going to try 2 more like that, and then we will be done with this section of notes. So it might be a little bit harder, but it is much shorter than the last one. The last one had several examples. So part D is I have 1 divided by 4 root 6 plus root 3. Whoa, I have 2 radicals there. So I'm going to have to do a little extra work. Well, not any extra work. I'm just going to simply multiply by the conjugate. So instead of plus, the only thing I'm going to change is a minus sign in between, but everything else remains the same. So let's deal with the top. 1 times that is itself, so 4 root 6 minus root 3. These do not have the same number underneath, so I cannot combine them. On the bottom, I'm going to distribute. So 4 times 4 is 16. Root 6 times root 6 is root 36. Okay, so I multiplied the 4's, and then I multiplied the root 6's. Now I'm going to distribute 4 root 6 to root 3. So there's an invisible 1 out here. 4 times 1. Oh, and this one's 4 times a negative 1, so negative 4 because 4 times negative 1. Now we're going to multiply our roots. So 6 times 3, that's 18. Okay? I'll do the next in blue so you can see my work. Now I'm going to distribute a positive root 3 to 4 root 6. Remember, there's an invisible 1 out here. So 1 times 4 is positive 4. Root 3 times root 6 is root 18. Finally, root 3 times root 3. So I have minus 1. 1 times 1 is 1. Root 3 times root 3 is 9. No, sorry. I'll drag that line out. So the rest of my work has to do with simplifying. So on the top, those are not like terms. So 4 root 6 minus root 3. On the bottom, however, I have 16 times 6 because the square root of 36 is 6. These cancel. Minus 1 times 3, right? The square root of 9 is 3. So on the bottom, I have 16 times 6 minus 1 times 3. I get 93. So all the denominators in the bottom are gone, and I have 4 root 6 minus root 3 in the top. Remember, we don't care if I have roots in the numerator. I just care that they're not in the bottom. So last one, part E, 3 plus the square root of 5 divided by 1 minus the square root of 5. Now, hopefully you start to see that there is a shortcut. Root 7 times root 7 is the square root of 49, which is 7. You can skip this middle part, right? The square root of 6 times the square root of 6 equals the square root of 36, which is 6. What do you notice about what they equal? They equal the number inside. So that means that square root of 3 times the square root of 3 is just 3. You can skip this part. The square root of 10 times the square root of 10 is just going to be 10. You can skip this middle part. Okay, so know that anything times itself with a root symbol is going to end up being the number. Okay, so let's use that knowledge to maybe make this one a little bit faster. We're going to multiply the top and bottom by the conjugate of the bottom. Notice that just changes the sign. So instead of minus, plus, the rest should be identical. Whatever I do to the bottom, I do to the top. So now we're going to distribute. So 3 times 1 is 3. 3 times root 5 is 3 root 5. Root 5 times 1 is just root 5 times 1. Okay? Plus, root 5 times root 5 is 5. I'm using that shortcut. Root 5 times root 5 is 5 because you get the square root of 25. So I did that in all the others, but this last problem I'm trying to get you to, so in all the others I wrote what it is. I'm trying to get you to see that it's the shortcut. Okay? So the bottom, I have 1 times 1, 1 times root 5, negative 5 times 1, so negative 1 root 5. Negative root 5 times positive root 5 is negative 5. Now don't go crossing anything out. Let's just combine like terms. So I can combine these. So 3 plus 5 is 8. And I can combine, so 8 is from 3 and 5. I can combine these and I'm only combining the numbers out front. Positive 3 and a positive 1 make positive 4 root 5. Sorry about that. That's my computer alerting me of a Google Meets. Okay, so it gives me a 10-minute warning. Now I'm going to do the bottom. So on the bottom I can combine these. 1 minus 5 is negative 4. And these cancel. So I am going to simplify these because all 3 of these can be reduced by 4. So I end up with 8 divided by 4 is 2. 4 divided by 4 is 1, and 1s are invisible. Over 4 divided by 4 is negative 1. So that leaves me with negative 2 minus root 5, because I'm dividing each of these by a negative 1. And that is it for that lesson.